Thank you guys for having me here today. Just out of curiosity, how many people here are not from Toronto? Show of hands. Oh, interesting. Welcome to our city. Hope you guys get a chance to explore a little. I recommend going to Pi. It's a really good Thai place around here. And for how many people this is the first physical conference you've been to since COVID? Oh, wow. How does it feel? No Zoom fatigue? No lag? It's good, right? All right, so it's truly a privilege to be here on the stage today. I'm gonna just try to figure out how to change slides. My talk today is gonna be about the ever so famous term tech debt. And as this is a product conference, I will be talking about how PMs fit when addressing tech debt and where we bring value. So before I start, I'm gonna take a quick minute to just share a little bit about myself. I'm an engineering grad from the University of Toronto, from the St. George campus. Shout out to the St. George campus if anyone's from here. Also an alumni at BrainStation. I worked as a software consultant for 2 years and quickly transitioned into product after that. I've worked in small startups to mid-sized companies, to enterprise, to Fortune 500 companies. I'm currently working at Wattpad. Some of my coworkers are here as well. We are an entertainment company with a web novel platform made up of about 90 million users. Previous to that, I used to work at Cineplex for about 3 years, Cineplex being the largest theater company here in Canada, with sectors in leisure and digital media as well. Some of my professional accomplishments that I'm proud of is I've worked in a company called See Live, and we built a live online platform which we showcased at Harbourfront for concerts and red carpet events. We hosted an event for a movie, the Mean Girls movie, during Pride Week, and had the privilege of having some of the celebrities on the platform as well, including Lindsay Lohan and Rajiv Surendra and Daniel Francis, if you guys know them. I led in building a payment process system that involved capturing and storing all financial transactions based on government standards, that leverage tools like Salesforce and PeopleSoft. And most recently, I was involved in the full stack modernization of Cineplex's main ticketing platform, which I will talk more about in this presentation. On a personal note, I am most proud of being lucky enough to be married to my wife, who was not very happy about this picture, so we came to a compromise there. It made her look unflattering, so I had to put that little sunshine over there. And I'm also proud of my 2 cats, which are also enjoying themselves a lot in this picture and let me live with them every day, so I'm really grateful for that. And I'm a homeowner. It took us 2 years to find something in Toronto, GTA area, which is really hard, and it was a bigger commitment than getting married for me, so I'm really proud of that. So let's get started. So I'm going to start by trying to attempt to define what tech debt is. And then chat through the value of product thinking when it comes to addressing tech debt, go through a few approaches and examples, and then finally summarize it all up. So what is tech debt? There are many analogies used when talking about tech debt. Tech debt can be seen as an untidy desk that, if left unattended, can turn into a garbage dump. It can be compared to a house that desperately needs renovation. The most common example being of that of a loan taken from a bank that, if we continue to miss payments on, we could lose our home and end up on the street. So this is close to home for me since I'm a new homeowner. And finally, the unhealthy diet. We could continue to be replenished by junk food, but sooner or later, if we don't start watching what we eat, we could develop health issues, have trouble moving, and overall have a poor quality of life. So as much as these analogies help convey what tech debt is and the feeling we should have around tech debt, there's certain, like, a reason needed for actually defining what it is and having a clear definition of the elephant in the room. So here are some definitions that I came across. Increased cost of changing or maintaining a system due to the shortcuts taken during its development. So I like the fact that it talks about the financial impact, but not sure about the term shortcuts. Oftentimes the product changes over time, the way the customers use it changes over time. So the decisions that you initially make at the start may no longer apply later on. So those may not necessarily be shortcuts, they were just what was relevant at the time they were initially starting. Another definition being something that accumulates over time and if left unchecked, will result in the depreciation of a valued asset. So I like this because it goes further than just cost and talks about a product as being more than just a service and lines of code. It's an actual asset that can change in value over time. Another definition being internal tasks you choose not to perform now, but run the risk of causing problems in the future. So this is the aspect of taking that on that debt that you need to eventually address. So I took some of these definitions, I looked at them, and I came up with something that I liked. And it's not necessarily perfect in any sort of way, but I wanted to make sure that for the purposes of this presentation, that I was clear of what I was talking about when I say tech debt. So to me, development effort, this is essentially tech debt in all its forms, whether that's writing code, maintaining it, creating a database, spinning up a server, anything to do with a technical effort. All of that is part of tech debt. So development effort needed to maintain or improve a digital asset. So this is even if there's something that, a product that you no longer are touching or making any sort of changes to, tech debt can still apply. And then if left unchecked, will result in long-term depreciation. So that talks about the debt piece where it's something that you are delaying in terms of effort that's needed, and going back to the point where a product actually has value and can change over time. So the forms tech debt can take. So apologies for the slightly graphic image here. It was in terms of me, I felt like it's the best thing that encapsulates the feeling I wanted to get across. And for any Rick and Morty fans, hopefully this is amusing. So shared definition is great, but tech debt is such a broad term that it's often hard to just wrap your head around by definition. So here are some forms tech debt can actually take. So architectural debt, for example, can be something like a violation of modularity, like the overall application has certain flaws in terms of how it was built, and it can affect performance and it can affect the robustness of that application. And this isn't something that can easily be fixed through just simple code changes. Build debt, for example, is looking at the process of pushing changes through. It looks at aspects like the number of manual steps involved or ill-defined dependencies in your code, and can also create room for production errors when you're pushing new releases. Code debt, this is probably something that comes to mind the most when people hear tech debt. This is the actual coding practices that are in place, how legible is the code that you are improving and working on a day-to-day basis. So I'm not going to go through all of these, but it shows the level of variation in our tech debt can have and the types of ways it can manifest. And it goes beyond just technical issues. Like, for example, people debt refers to issues related to the distribution of knowledge within your development team. So if there is a high dependency on a select few individuals, they become the bottleneck and reduce the overall speed of development. Test automation is a big one that often gets ignored, and this can apply to actually existing functionality. So being able to have automation and test automation on existing functionality will actually speed up the cycles for you to be able to build new functionality. So all of these are issues that can be seen as things that are under the hood, and oftentimes can be completely ignored by the business. Because as long as the product is performing at a level that suits the business's needs and customers are happy, it can be ignored. But eventually, the cat comes out of the bag. And this was supposed to be a GIF where the cat comes out of the bag, but I guess it's not working, it's fine. So there often is a tipping point where the accumulation of debt is now affecting the business in more than just, in a more direct way. So users may be leaving because of functional bugs or performance issues or downtime. The brand image might be suffering because of security vulnerabilities or inconsistent UX across the product. And there may be frustration being developed between the business and the development teams because of a reduced delivery of new functionality. So this is where product steps in. So let's bring out those brooms from the closet. Let's come up with those cleaning best practices. Let's identify whether it's a plumbing issue or whether it's a crack in the foundation or if you just need a good spackle job. Let's make sure that we start paying down those loans one transaction at a time. And let's hit the gym, stay consistent, and finally come up with that meal plan. Okay, so when it comes to tech debt, this is why there's value in product. We sit between the higher executives of the company and the people that are building the product. Product managers have a lot of different roles. We are the voice of the customer. We look at the market trends. We are creative. We think outside the box. But for tech debt, this is why we are important. We bridge the gap between these two parties. The next few slides, I'm going to talk about how we should be talking to execs in relation to tech debt and how we should be talking to engineers. I will be using the same terminology for both, but the approach is significantly different because of where they sit. So dear execs, the first step is understanding the vision. What does the business care about and what is the long-term strategy? This should also uncover where the concerns lie when it comes to tech debt. Are they worried about the downtime? Are they worried about the user complaints? Are they worried about, they're frustrated at how many times we've missed timelines for delivery? And most of the times there's going to be more than one of these that they're concerned about at once. And it's up to product to identify which they're worrying about more. And oftentimes this is related to where they're losing the most money or where the concerns are. So the next step is building transparency and actually contextualizing that tech debt as much as possible. So part of that is having that shared understanding of what tech debt is, knowing the different forms it takes. It's also showing it through actual profit and loss statements. So we can actually say, because of this, we're seeing this much in maintenance cost, or we are losing this much amount of profit because of delayed releases. And this can be much easier to actually do if business execs, product, and engineering link together and are able to actually come up with the total number of resources that are required to run the product. It's either a product or even like your key user journeys, for example, you could do that for. And then through that transparency, we should be able to now have a clear sense of the prioritization and come up with the high-level milestones that create a path to how we plan to execute. So this is bread and butter for product, so I'm not going to go too much into that. And then lastly, we need to make sure that we have a way to monitor progress in a contextual way, leveraging dashboards that highlight key metrics that link back to the business and product objectives that showcase our return on investments. There should also be an understanding, especially in the start, that it will take time to build momentum and to move the needle in the right way. So expectations need to be set to leave room for it to iterate. So I like this quote a lot, and it sheds light into why some of the work that I mentioned in the last slide is important. If a business is not aware of the actual cost they're experiencing to run the product, how do they know it's profitable? So the value the product generates should be higher than the sum of the expenses to run it. A well-known study by Stripe, the graph you're seeing on the left there, showed that 33% of developer time is spent in tech debt. So to put this into context, if you had a company, say, of 50 engineers, each being paid $100K, that would be $1.6 million a year that you're spending in tech debt. The graph on the right there shows the loss of revenue a company can experience by a mere 2-month delay in a product launch. So say you have a monthly revenue growth rate that is fixed around 15%. Over a 2-year period, you could have lost 25% potential revenue. And by month 24, your monthly recurring revenue is 30% less than what it could have been. So each time tech debt is broken down into the costs that it incurs on the business, we get a clearer picture of how big of a concern it actually is for the company. Here's another example of how we can actually contextualize the costs. If devs here are tracking the amount of planned work versus unplanned work that they are doing each sprint, you can also notice the time frame that we're looking at here. So the more data we have, the better we can make decisions. And it's good to set expectations here. So for example, if you're currently seeing 40% of your time is spent in unplanned work and different types of tech debt, what is the benchmark that you should be aiming for? Usually in healthy companies, that's around 15%. Now let's move on to our engineers. So we can see that our communication can be broken down in the same categories, but we're talking in different types of context here. So when we talk about the vision, it's now on us to articulate a clear narrative and a compelling call to action to rally engineers behind. And it has to be focused back on the business. And we cannot fix all of our technical debt, nor should we. And we cannot just do what makes engineers happy. It has to serve the business. Transparency is now needed from engineers. We need them to articulate how we can actually go about fixing the issues we've called out. We need engineers to be clear in assessing the effort involved, calling out the knowns, the unknowns, and the risks. And we should give room for this. We should let them investigate, spend time understanding the problem space. And it should not be done in a black box. It should not be, let me go take 3 months to fix this and come back and let you know if it's done or not. It should be okay for them to also say no, or I don't know and I don't have the expertise for this, without them feeling a risk of losing their job. Engineers are not necessarily hired to fix tech debt. They're usually hired to build new functionality. So when they are placed in that position, you have to give them space to learn and grow, and bring in specialized consultants and so forth to be able to help train them and get them to where they need to be. It should also be okay for them to say, sorry, I already said that. So the inputs from the engineers should now be able to allow us to further prioritize our plans by looking at what are quick wins versus tasks that are going to take longer. And lastly, going back to the feedback loops, there will be certain signals that engineers will have more understanding towards that we should be able to use and communicate upwards. So for example, how well are our servers doing when handling the load? These aren't signals that will show immediate benefit to the business or the customer, but it is an indication that we're moving in the right direction. The aggregation of such data can really help with the impact we're making on tech debt. Since tech debt isn't something that we have to pay down slowly, and it takes time. These signals actually help with showcase those incremental changes. So these visualizations actually are a good way to show how not all tech debt is the same. So what you're seeing on the left there is a visualization of the code health of Apache's Zookeeper codebase. Each circle represents a file with source code, and the color indicates the health of those files. So blue being healthy, yellow being a warning, and red being of serious concern. Now the image on the right, however, shows the hotspots of where developers are making most changes. So really, if there's a file that's not being changed and doesn't require as much attention, is it really necessary to fix and improve its code quality? So a combination of code health and developer relevance can help us to prioritize the right tech debt. We can also look at concepts like change coupling. So this is, for example, a case where every time you're making a small code change, you are being forced to change 2 other files or 3 other files. So is that necessary? And are there ways that we can refactor the code for that? So all in all, the point here is that we cannot fix all the technical debt at once, nor should we. Now, in terms of the next few slides, I'm going to go over high-level approaches of addressing tech debt. These don't necessarily need to be mutually exclusive, so there may be possibilities where your company is using more than one approach simultaneously. So the thin slice. Hopefully everyone had a good lunch and this is not tempting you in any way. So this approach is looking through multiple layers of the tech stack that require attention and refactoring or rebuilding those specific layers to the desired state. So you want to go about doing so in a way that benefits the business as well as helps you validate that you're building the right thing. So this can be done by picking a small business use case with minimal impact to the business or the user, but still helps to show the benefits of what you're building is helping address tech debt. So this is actually the approach that we took at Cineplex. At Cineplex, the main ticketing web platform, Cineplex.com, required multiple layers, attention in multiple different layers. So there were efforts made on a new design system, We moved to a new modern front-end framework. We refactored the back-end APIs. And we also fixed some of the deployment process issues. So we started this work by focusing on a very small business case, but that showed multiple benefits to the business. Promotional pages at Cineplex were taking 2 or more weeks to build, and it required a high dependency on developers. Once we applied our new layers of the tech stack, our marketing team was enabled to create and launch their own pages within minutes. So we were able to do that by creating standard templates, standard reusable templates, and we're able to host those in our content management system. So as leadership bought into our efforts, and we were suddenly given the green light to use our new stack throughout the website, we had to level set expectations. This approach requires room to evolve, especially since we're looking at such a small slice and such a small use case. So as we started looking at other sections of this website and looking at the traffic on those pages and the types of content on those pages, we had to make sure that we were making adjustments to our solution and validating if it still worked. So this is actually some graphs that I used at Cineplex that kind of broke down the different factors when prioritizing which sections of the site to look at. So we looked at revenue, we looked at dev effort, and we looked at user experience. And we were optimizing for the areas of the highest revenue yield with the lower dev effort and the most user impact. All right, so the platform approach. So the platform approach is in some ways the opposite of the thin slice approach. Here we want to find as many use cases as we can that have similarities and patterns and standardize those experiences. You essentially are creating a horizontal layer that hides away certain complexities and allows product teams to simply plug and play with those modules for their respective use cases. So Airbnb is a strong voice of this approach. An example they've implemented is the Homes platform. This platform provides user tools, APIs, components, documentation to each of their product teams. Their product teams are broken out into like category teams that address different types of use cases and have different user flows there. But one thing that's common between all of those categories is that the way that people check availability and book their experiences. So the Home platform actually helps to standardize that. So there are some pros and cons that are mentioned here as well, but this is actually the approach that we at Wattpad here are using right now. And just checking time. I have some time here, but the modular approach is not something I want to go too much into detail, but the main thing to call out here is from a product perspective, supporting development is by identifying groupings and business logic and the dependencies that are tied to them. For example, the relationship between like a payment service and a subscription service. You want to be able to identify when certain transactions need to take place and how do renewals affect like the payment process. A big part of modularity is knowing where the delineation should lie and how they are correlated. All right, summary. So what are the takeaways? Tech debt can take many forms. It's important to be clear of what forms apply to your business. Represent tech debt through financial statements. This is very important. So the value of product generates should be higher than the value of some of the expenses it has. Product is key when addressing tech debt because of where we sit in the organization. We should focus on identifying and communicating a clear vision, being transparent and contextual about the tech debt, plan by prioritizing and setting milestones, and have a constant feedback loop that shows progress we are making throughout our journey. Lastly, having a systematic approach helps knowing how best to support your engineers and bring value to the business. This approach should be decided based on what best suits your business, as well as how your development teams are structured. And that's it for questions.
Cool. Do we have any questions?
Go ahead.
So, you keep adding these technical depths and not be able to compute everything fully, right? So, sometimes your backlog keeps growing with the technical debt. How do you manage that? Like, I feel like in our current products we're working, everything is not critical. So, we solve solve all the things, like the critical ones, but then the ones that are minor or really smaller ones, we just add it to the backlog and keep adding it. And now I feel like, oh my goodness, it's a very big backlog, and I have no idea that I'm going to complete that. So how do you handle those kind of things?
Yeah, it's a good question. It's one of those things that often as you're talking to engineers, they always bring up, their experience dealing with certain code and them not liking having to struggle through this piece of functionality or so forth, and not wanting to touch certain functionality because of how much tech debt is accumulated there. But it has to go back to the business and your customers. Is there a way that you can actually articulate or show how that tech debt is costing your business? Is it affecting your customers in a negative way? And show that in some sort of way, whether it's through looking at analytics, whether it's looking at the cost of those added servers or whatever it is on the technical side, to be able to clearly articulate that back to your executives. And if it's engineers that are coming to you and saying, hey, I don't look at all this tech debt, tell them to find a way to show you that this is costing us more money, right? And flip it back on them. Any other questions?
Cool. Do we have any more questions? Yeah.
Thanks for all the approaches, but what would you recommend, when we build this product roadmaps and stuff, year-end planning, putting aside say 70-30 approach, like 75% for product development or whatever things we want to work on, 20% engineering capacity for this tech debt kind of things, because we know that it's not a one-time thing. It will keep happening as we are building more stuff, so that they have a way of how to handle this on an ongoing basis rather than on a reactive basis. Just wanted to hear your thoughts on that.
Yeah, that's a really good question. So I would never recommend that everybody stop their day-to-day and just focus on tech debt, because that in a way stops you from collecting data on your improvements. So if you're not building new functionality, you're not still going towards certain other business objectives, how do you know you're improving your overall processes in a way that's helping them move faster and so forth? So there has to be a balance between how much tech debt you're addressing and how much of the other objectives of the business you're looking at. And often those feed in to be able to show improvements. That 70-20 rule and all of that's often, to my experience, very arbitrary. And again, ideally, and this is, a lot of this is stuff that I've looked at through papers as well as some experience that I've had, but it's the ideal situation where you're able to fully articulate and show it's costing you this amount of dollars because of your tech debt. This is how much interest you're paying on your tech debt every year. And then based off of your overall financials, you can actually say, okay, this is how much we should be allocating in terms of resources to address tech debt then. And that's more, it's not necessarily as arbitrary, but often executives don't spend enough time there. So that's the one caveat there, I'd say.
Okay, thank you.
I guess we can accommodate one last question if anybody has another question.
Awesome. Thank you guys for your time, and appreciate